Hi class, let's take a look at problem 5. Now in problem 5, for the evaluation of the derivative, I'm just going to use the following definition. In this case, we're going to use this definition but with a regular x value. And remember that technically in this case, h represents this distance as it becomes infinitely small. That's going to represent technically the tangent line or the slope of the tangent line around any x value. So this particular one, it's going to turn out a little bit messy, and keep in mind that they're asking us to use a definition. So for this particular problem, the values of f prime of x is equal to the actual limit as h approaches 0 of the function f of x plus h minus the values of f of x divided by the values of h. Let me fix this plus. And for this particular problem, this actually represents, since your function is 1 over x, so in this case, this actually represents the actual limit as h approaches 0 of, and we're going to have 1 over x plus h minus technically 1 over x, which is our function, divided by h. And then the step that we're going to take here is I'm just going to acknowledge that the LCD is equal to, well, technically h over 1, but technically the values of x times x plus h. And what I'm going to do is multiply x times x plus h, and at the bottom x times x plus h. Multiplying by the LCD, it's going to simplify the complex fraction that we have. And remember that on the top, we get to multiply it times these two values. So we're going to end up with we have to carry the limit throughout. So this is the limit as h approaches 0 of, once you multiply times the LCD and x plus h, you're just going to be left with an x on the first term minus, and then the second one is going to have the x plus h all over, and this one's going to have an h times x times the values of x plus h. And then keep in mind that the LCD, what it's going to do once you multiply it times x plus h, it cancels the x plus h, but not the x. So that would be this x. And then from this one, only the x, so leaving us the x plus h. And then we have to be very careful here. We're going to be distributing out that negative value. And then our expression within the limit actually means that we have the limit as h approaches 0 of the values of x minus h divided by technically h times x times the values of x plus the values of h. And then good news, we have some values simplifying. The actual x's cancel out. And then we're looking at this is being equivalent to the actual limit as h approaches 0 of negative h over h times x times the values of x plus h. Okay, at this point, we're going to be canceling the h value. I'm just going to put a disclaimer. Keep in mind that h is at the bottom. So you can either write that h is not equal to 0 or h is a value greater than 0 to represent the distance, but that disclaimer is needed there. And then technically we're looking at this is equivalent to the actual limit as h approaches 0 of negative 1 over, we technically have an x and an x plus h. And then at this point, we can actually evaluate the limit. Let me just rewrite that next step here. And once you evaluate the limit, you don't have to carry the expression. This is going to be negative 1 over the values of x times x plus 0, which is going to simplify it as negative 1 over the values of x squared. From here, let me just rewrite the final answer. And then the actual derivative of this function, it's going to be negative 1 over x squared. and technically x is not equal to 0, we have a discontinuity on our function. At x is equal to 0, we technically have an asymptote, and that would be the final answer. So a little bit messy, but not that bad. This would be your solution if you were to be actually using the definition. We'll talk about shortcuts later.